Good morning, class. The session is being recorded. And so again, as always, if there is any issue with privacy, make sure not to put anything in the chat. Audio, video must be muted. And if I ask a question, please don't participate if there is any issue. Also, you can change your name to your initials. So first and foremost, again, there are many formulas that hopefully by now we are very comfortable with, okay? Here's the second part of the section, deals with implicit differentiation. All right, so what happens is that when we want to differentiate, either the function is given as a function of x, which is defined explicitly, okay? We are familiar with various formulas, we know how to differentiate. Or it may not be defined explicitly, meaning x and y are intertwined, they are on the same side, and they are given implicitly. So you have a choice of solving for y, if possible, and it's not all the time, or not. Either way, if you can solve for y, you can go back to the previous one and solve it, so differentiate it explicitly. If not, you have no choice but to do it implicitly. So let's look at a very simple case. We see that it can be done both ways, and then we generalize it. Okay. The explicit format requires solving for y, and in order to do that, we take the following steps. So let me just show you the intermediate step. We move the 4x, so this becomes 2y equals minus 4x plus 10. We are going to divide both sides by number 2. And we get to this answer. Needless to say, y prime or dy dx is negative 2. It's very simple, class. Or we can differentiate it implicitly as it's given, term by term. 4x, the derivative is simply 4. Plus 2y is plus 2. Now what is the derivative of y? Y prime or dy dx. Because y is the same as g of x, class. Remember, y is like g of x. Okay. Y is like g of x. So 4x gives you 4, 2y gives you 2y prime, and a number gives you 0, any number. Now, whether I write y prime or dy dx makes no difference. The only reason I do that because I want to refresh your memory that they mean the same thing. So your next step is to move the 4. Divide both sides by 2, and that's your final answer. And as you can see, identical answers as expected. Identical answers. And that's the idea. So whether you do it implicitly or explicitly makes no difference. But the advantage of implicit is that it works even when you can't solve for y explicitly. All right, here's another example. Again, you can solve for y, but you don't have to. I hope you realize and you remember the equation of a circle centered at 0, 0 is x squared plus y squared equals r squared. So therefore, in this example, the radius is 5. So as an example, this is 5, 0. Okay, and This is 0, just as an example. So we want to find y prime. Okay, so we are going to differentiate this term by term. X squared gives us 2x. Y squared gives us 2y, y prime. It's important to know it's like g of x to the power of 2. The derivative is 2 g of x to the power of 1 times g prime of x. This is the extended power rule, right, class? So that's how you do that. Therefore, this becomes 2. Let's just write it underneath. So this becomes 2y prime. Okay. And now move the 2x divide by 2y, drop the common factor of 2, and this is the y prime. Now, the next step is to find the equation of a tangent line. So what do we need? We need a pair. We have it. We need the slope. And so what is the slope? Well, plug in to y prime, and that becomes a slope. So replace the x with 3, so you get minus 3 in the numerator. 4 instead of y, so negative 3/4. That is your slope. The good old point slope. Y minus y1, that means y minus 4 equals m, that means negative 3/4. X minus x of 1, that means x minus 3. And now, let's write at top of it, the next step. And this is y minus 4. Now we are going to distribute negative 3/4 x plus 9/4. And what do we do now? We add 4. 4 is 16 over 4. And 9 becomes 25 over 4. And this is the final answer. So I hope you see it's really not too bad. Okay. All we do is going to practice with this, okay? All right. Let's differentiate this term by term. X cubed plus y cubed equals 6xy. Okay. X cubed, 3x squared. X cubed is 3x squared. Y cubed, 3y squared, y prime or dy dx. And because it says dy dx, we're going to use dy dx. Now the right side is a product of 6x and y. In other words, you're dealing with this piece times this piece. So I want to just show you that part in case. So this will give you 6 and then times y by the product. And this piece will give you y prime times 6x by the product. So take a look. X squared is 3x squared. Y cubed is 3y squared. Y prime or dy dx. And the right side uses the product. Now, it's important to move things around such that we can solve for dy dx. So we can, for example, move this one because this one is also dy dx. And move this one. So notice what happens. This takes a negative sign on the other side. This takes a negative sign on the other side. So you are going to factor the left side. So you take out dy dx. Of course, the number 3 is in common also, but what matters is dy dx. We are going to divide both sides. By 3 times y squared minus 2x left side is left with dy dx, and the right side is 2y minus x squared over y squared minus 2x. The only thing I want to add, class, if we go back to this step, the way we move things around, if we change them, in other words, remember the piece involving dy dx was moved to the left. What if we had it the other way around? The piece with the dy dx was moved to the right. Then what happens is that this, if you move it differently, looks like this. And it's absolutely the same thing. X squared minus 2y over 2x minus y squared. And by the way, this cannot be simplified. Okay, class, you're done. If you multiply this one, the numerator by -1 and the denominator by -1, you get this one. So they are identical. Okay, everybody? Let's move on. We are going to differentiate this. By putting a raised dot in between these two. And say we are multiplying 4x squared by y, therefore we are using the product rule. So 4x squared gives us 8x times y. Y just gives you y prime times 4x squared by the product rule. Plus 2y squared, that's simply 4y prime or dy dx. Right side is a number, it gives us 0. So this is this part, everybody. And 2y squared gives you 4y prime. It's just simple. You have to move the 8xy. So we are going to move this to the other side, becomes negative. And we are going to factor the other two by taking out y prime. You divide both sides by 4 times x squared plus y. The left side becomes simply y prime. And the right side, we can factor out the 4 out. Okay. And this is your final answer.
I have a quick question.
Sure.
So on the second line down, can you explain why we have the 4y prime? Is that because we're trying to find it or because the y is to the second power?
We are differentiating 2y squared. So let's differentiate 2 times g of x squared. How do we differentiate that? 2 times the exponent is 2, and then times g of x raised to the power of 2 minus 1, right? By the power rule and by the chain rule times g prime of x, where g of x is y and g prime is y prime. 2 times 2 results in 4. Does that make sense?
Yeah, that makes more sense. Thank you.
My pleasure. Class, if you have a question, you're more than welcome to ask. Remember, you're never alone. If you have a question, you are doing everybody a favor. I mean that. So I appreciate your questions. All right, here's what comes next. So let's give everybody a minute. See if we can do the first step, which is, calculus. The rest is algebra. Okay, let's see what we come up with. All we have to do this step by step, term by term. So let's do that. See what we end up with. Four x squared, everybody. Can anybody tell us 4x squared? What's the derivative? The good old 4x squared. 8x. Done. Plus 6y.
Just 6.
No.
A 6 dy dx.
Beautiful. Because y is not the same as x, class. If we have x and y is a function of x unless otherwise mentioned. So the derivative of y is always y prime or dy dx. Always. Okay, done. How about y squared?
Is it 2y dy dx?
Beautiful. Right side, everybody?
0.
Beautiful. It's a number. And you're done. This is the end of calculus. Calculus is done. So what do? We move the 8x, we make it negative on the other side, and we factor out the y prime because we are solving for it. So take a look. Now we are going to divide by whatever is sitting next to y prime. Everything that is sitting next to y prime. Do you see that? Because we want to get y prime by itself. And so this one cancels out this one cancels out this one, and the left side is y prime. And the 2 goes away in the denominator, and the numerator changes to negative 4x, and everybody's happy.
I'm just a little confused.
Sure, go ahead.
How do you keep getting y prime?
Okay, what is the derivative of x? Everybody, what is the derivative of x?
X prime? No, just 0. Well, no, 1, right?
Beautiful. What is the derivative of y?
dy
Everybody,
dx.
either y prime or dy dx.
Thank you.
Sure. I hope that answers the question. Are we clear on that? Perfect.
Yes.
Because remember, it is only x, the derivative is 1. Not only x, any independent variable. If you're taking the derivative with respect to t, the derivative of t is 1. If you're taking the derivative with respect to theta, the derivative of that one is 1. All right. Let's do the same thing here. It's the product rule, everybody. Let's give everybody a minute. See if you can do the first step. We do it together shortly. See if you can do this, and you are in good shape. As long as you can do the first step very carefully using the product rule on the first piece, x times e to the power of y. Let's see what we get. Try this, everybody. We want to see if we can do the first step very carefully. Bear in mind, this is x times e to the power of y, okay? I think this is simple, so we are interested to see if we can do this part, okay? Bear in mind, we are using the product rule again, x times e to the power of y, okay? So for x times e to the power of y, what do we get? X gives us 1 times e to the power of y plus e to the power of y. Can anybody tell me what is the derivative of e to the power of y? First, let's start with this. When we differentiate any exponential, the first thing we say is that the derivative of any exponential is itself. You remember that? So what is the derivative of e to the power of y?
Y.
Is e to the power of y. It's exponential. Because the exponent is not x, it's g of x. Remember, y is the same as g of x. Literally change it. E to the power of y is the same as e to the power of g of x and differentiate it, okay? Which becomes e to the power of y, y prime, or e to the power of g of x, g prime, okay? So I hope you remember the basics that we have done. And so x gives you 1 times e to the power of y plus e to the power of y gives you itself times g prime of x, which means y prime, plus 2y cubed is 6y squared y prime, and the right side is 3. Okay. And so basically you move e to the power of y to the right, becomes negative and you factor the other two pieces. Okay. All right. Now the rest is history. Just divide by the parentheses. And we're done. Okay. Let's look at the next one. We want to differentiate this to find the slope because we are interested in equation of a tangent line. We need a pair, we have it. We need to differentiate this using the product rule. Therefore, what is it? What is the derivative of x squared times? I put a raised dot so everybody can see we are using the product rule. What is the derivative of x squared times y squared? How do we do that? X squared gives us 2x times y squared. Y squared gives us 2y prime, or dy dx, times x squared, and the right side is just a number, so it doesn't matter, it becomes 0. So x squared gives you 2x times y squared. Y squared gives you 2y prime. Again, you're done. You simply have to move the 2xy squared to the right and divide by 2yx squared. So number 2 cancels out number 2, negative sign remains class. X goes away, this becomes x, y squared becomes y, and this y goes away, and it simplifies to negative y over x. This is not the slope, this is dy dx or y prime. Let me in fact write that because I want to again remind everybody y prime dy dx, same thing. Okay, now plug in and it becomes this slope. So if you replace the y with 1, you get negative 1 in the numerator. If you replace the x with negative 1, you get negative 1 over negative 1, which is positive 1. So that's the slope. Now, of course, y minus y1 equals m times x minus x sub 1. We've seen it a billion times. So y minus 1, m, which is 1 times x minus minus 1, which is x plus 1. This is x plus 1. Move this negative 1. And you get x plus 2. Okay. A little bit of a practice. Okay, class, you'll be comfortable with this. We are moving to sort of a new subject that follows this stuff. Related rates. What's happening in a related rates is that we really have a situation where quantities are related via a function, a formula from algebra, from geometry, from trigonometry. And that's a piece of knowledge from the past we should have. And then basically, one measurement is easier than the other. So it's measured and the other one is calculated. That is called the related rate problem. So in order to do that, the only independent variable in a related rates is time. So it's important to understand it is no longer the derivative of x, which is 1. It is only t, the derivative is 1. So what is the procedure? The procedure is to find an equation that relates the two quantities and then use a chain rule to differentiate with respect to what? The only independent variable here is time. Okay. An example that is given here, when we are pumping air into a balloon, it's easier to, and you can obviously see the volume and radius are both increasing, but it is easier to measure the rate of increase of volume and then calculate the rate of increase of a radius. Here's a similar situation which will help us understand the concept. Okay. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. We want to know how fast the radius of the balloon is increasing when the diameter is 50 centimeters. So it's important to understand a couple of things I want to discuss. Number one, let's discuss the given and missing first verbally. Remember, you're dealing with an application word problem, and word problem ultimately requires translation. We're going to discuss that in a moment. So verbally, we are given the rate of increase of the volume with its unit, and missing is the rate of increase of the radius when the diameter is 50 centimeters. So this is what we want to find, the rate of increase of the radius. So the very first thing we need to know is the relationship between a volume and the radius of a spherical shape, okay? And that is 4/3 pi r cubed. So the very first thing we need to know this. Also, we need to know that D, just write it here, D equals 2R. Therefore, when we say diameter is 50, that means the radius is 25 centimeters. Now, let's write this symbolically. And that's what you need to know for every question to be able to handle it easily. So here's what happens with this question. The rate of the increase of the volume of the air is this. So that means what? How do you write this? The rate of increase of the volume, that means dV dt is 100 cubic centimeters per second. Of course, we wrote this relationship. It's important. The volume is 4/3 pi r cubed. The V is 4/3 pi r cubed. V. Let me write that here. So dV dt is given. So what is missing? dr dt. At what point? When the radius is 25 centimeters. If you can do this, I can't imagine anyone having problem finishing this off. And if you can't write this, there is no way to finish the work. Now, you may not have to write this as long as you know what you're doing, but it's really a good practice dealing with applications and word problems to translate. So basically, we have translated the question. And so with that being the case, V equals 4/3 pi r cubed, dV dt is given, find dr dt. And all you have to do, find dV dt from the formula. Now, understand that volume is a function of radius, and r itself is a function of time, and therefore r is not the independent variable. So in essence, you want dV dt, and the intermediate variable is dr. So dV dr dt. So you are going to differentiate this with respect to r, and then tag along dr dt. So how do we do that? dV dt equals 4/3 pi is just a number, everybody. So write 4/3 pi and then differentiate r cubed. How do you differentiate r cubed? If it was with respect to r, you would just write 3r squared, and that would be done. But it's not, so 3r squared dr dt. So the point is The derivative of this part is this part, everybody. 3r squared dr dt. We get rid of number 3, and we are done with calculus. Now you have a choice, plug in. That means right here, the left side is 100. The right side, 4 pi is not missing. Remember, that's just pi, 4 times pi. And replace the r with 25. So it becomes 25 squared, solve for dr dt. Or solve for dr dt, that means divide by 4 pi r squared. Division by 4 pi r squared means multiplication by its reciprocal. Remember, we are dividing by 4 pi r squared. So this is how we write this. And now we do the replacement. dv dt, 100. Okay. 1 over 4 pi r squared. And you need to simplify this. I hope you know that 4 times 25 is 100. So it's 1 over 25 pi precisely. And that's perfect answer with the proper unit, centimeters per units of time, which was seconds. And if you insist to go with the decimal notation, you better carry out a lot of decimals. So you want to pay attention to what they ask you. The only thing is left for me to discuss here is the units. I want to make sure everybody understands how the units work. The units of volume, okay, over the units of time. See, 100 cubic centimeters per second. For the RDT, the units of the radius per unit of time. So units of centimeters per second. If you work it out here with the units, in other words, instead of 100 class, put 100 cubic centimeters per second. And instead of just 25 squared, you put 25 centimeters squared. So centimeters squared goes away and you have only one of them. So in other words, whatever you do to numbers, you do to units. It will work perfectly. Here's the last question of the day. A small rock is dropped into a lake. Circular ripples spread over the surface with the radius of each circle increasing at the rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. So I hope you realize the very first piece of information from geometry we need is the relationship between a circle and its radius. So I hope everybody knows that. For example, the area of a circle equals, anybody? Area of a circle equals so area of a circle is pi r squared. Diameter d equals 2r, circumference is 2 pi r. Those are some examples. I hope everybody's comfortable with those. Again, piece of information from geometry you're supposed to know. I just went over that. So let us write the question symbolically. What is given and what is missing? First and foremost, we write a equals pi r squared. We came up with that, okay, because we remember this from geometry, so we need that. So a equals pi r squared. So what is given is that the radius of the circle increasing at the rate of 3/2. So dr dt is 3/2 feet per second. And what are we looking for? dA dt. At what point? When r is 4 feet. So we wrote the formula for the area. dr dt is given as 3/2 feet per second. R is given as 4 feet. What is missing? dA dt. And that's it. As long as we get here, we are practically done. So what happens next? All you have to do, differentiate your equation on both sides with respect to t, which means t is the only independent variable. So I want to quickly show you that. So that gives you the a dt equals pi times r squared. That gives you 2r dr dt. So that means 2 pi r dr dt. I put the pi first, meaning pi is a multiplier and it doesn't go away. It's just a number. And so now just replace the r with 4 and replace the dr dt with 3/2. In fact, replace the r with 4 feet and the dr dt with 3/2 feet per second, because I want to discuss the units as well. So if you put feet here, and for this one you put feet per second, you get square feet per second, okay? And so four cancels out the 2, or 2 cancels out the 2, you have pi and 4 and 3, which is 12 pi. So this is the precise answer, everybody. 12 pi square feet per second. If you want to go with decimals, you go with a bunch of decimals. So the answer is 12 pi square feet per second, or roughly about 37.6991 square feet per second.
So we substitute dr over dt for the rate at which the circle is increasing. So we
Absolutely.
always, okay.
dr dt, that is referring to the rate. Remember the rate, and in this case, of course, is the instantaneous rate.
Okay, got it. Thank you.
My pleasure.